Allô? It's working. Laisse-moi voir. Can she put this here? Can she connect there? No, ahí hay otro. No? And there, behind. Again.
Awesome.
Thelma, there. Para que así pueda...
Me pone al medio.
Sí. C'est la branche. Tu dois mettre son ordinateur.
Non, mais ça, du coup.
Ah, ça c'est à toi?
Oui, c'est pour ça que je te demandais s'il y
Non,
avait,
non,
si
non,
tu voulais
non,
que je me
je
mette à un
pensais-
endroit
non, non,
particulier.
je pensais que c'était elle. This close. Ah, ok.
All right. Thank you. Get ready. Ooh. Get ready. It's the end of the day, so. Oops. Anywhere. Anywhere. Well, it's a good arrangement. Okay. Ready? Okay. Good evening to everybody, and very welcome to this very important event that is going to talk about comprehensive conservation, and we are talking here about the challenges and the urgencies. So I thank Mary for inviting me to moderate this session. It's a pleasure for me, and even a greater pleasure to be surrounded by great specialists that are going to provide us with important inputs from different views, as I could gather from our initial conversation. So, with that, we have our 5 panelists, and we are going to start with Sean. To put a little bit closer, okay, thank you. It's because I'm always afraid that it is going to explode, you know, it's making that huge noise. We all know that conservation of ecosystems and species helps to maintain the planetary health, and this includes also the human and the society health, and also is a precondition for the climate resilient development. So it's interesting to see that the IPCC talks about adaptation in the adaptation report, indicating that in between 30 to 50% of the land, be it terrestrial, oceanic, or freshwater, should be conserved in order for us to have a protection of the biodiversity, also to build ecosystems resilience, and also to ensure essential ecosystem services. IPCC also talks about the adaptation of conservation strategies by building resilient and planning for unavoidable change. And this could help reduce the harm, but will not be possible for all systems. We know already that we have fragile systems like the coral reefs, we have some types of forests, we have also the permafrost systems that are already in a huge danger. So even if we have the political will to conserve these systems, if we don't manage to have, you know, a limitation in the global warming, these systems are going to be unavoidably lost. We have already been looking at extinctions of a species, shifts in the species, and this is the danger that we found. So with that brief introduction, I would invite Sean Maguire from the Clean Air Fund. Sean, you're there. So I would like you to give a better introduction of yourself. I'm just saying that you're from the Clean Air Fund. And I would appreciate if you could say a little bit more about yourself and also about your presentation on pollution and biodiversity as well. Thank you.
Great. Thank you very much, Thelma, and it's a pleasure to be here. My name is Sean Maguire, and I work for the Clean Air Fund. The Clean Air Fund is a philanthropic initiative which was set up to accelerate action on air pollution everywhere. And air pollution is one of those cross-cutting issues, and I just want to talk a little bit about how air pollution impacts on biodiversity and ecosystems, and talk about how that links into climate change. The connections of air pollution to climate action are very, very clear. Many of the sources of air pollution and climate change are exactly the same, namely fossil fuel emissions. So, you know, if you burn fewer hydrocarbons, you benefit human health and planetary health. That's very clear and very simple and straightforward. So we spend a lot of time encouraging the climate community to mitigate climate change faster. If they mitigate climate change faster, it will forefront tackling air pollution. But air pollution is not just a human health and climate issue. It's also a real threat to biodiversity, to food security, and to rural prosperity. The most commonly known story in this area is the story of acid rain. And we all know, those of us who've been around a little bit longer, this was the story that was really prominent and visible in the 1970s, particularly in Europe. It's less spoken of now, but it was absolutely huge then. And essentially what this was coal-fired power generation pumping sulfur dioxides up into the air. And then that sulfur dioxides mixed with water, and it formed sulfuric acids, which then comes down with the rain and is blown by the winds, and it essentially poisoned the lakes and the rivers and killed all the forests in Northern Europe and in Scandinavia. So it's still a problem now, but it's not as big as a problem as it used to be. And one of the interesting things that happened with acid rain was it led to the very first concerted international action to tackle air pollution for the benefit of ecosystems and nature and the climate. And that was the Convention on Long-Range Transboundary Air Pollution. It's the most successful and least well-known international treaty in this space. It's been in existence for 40 years, and under it, basically North America and the whole of Europe have agreed to take measures to reduce the emissions of nitrous dioxides and sulfur dioxides that are plant and animal harming. But nowadays, the much bigger issue is ozone, ground level ozone. Obviously, you know, atmospheric ozone is something we love and we want more of. Ground level ozone, we don't like, we want to get rid of it. And the reason is, it's very damaging for crop life. It damages plants, and it badly affects their growth. And ozone is created by the reaction of nitrogen oxides and volatile organic compounds in sunshine. Ozone is what's known as a secondary pollutant. So if we reduce nitrogen oxides and VOCs, as they're known, we can improve crop yields and biodiversity. And where do NOx, as it's known, and VOCs come from? Again, it's exhausts and emissions from power generation, from fossil fuel powered transport, reacting with other pollutants from vehicle exhausts, from oil refining, from petrochemical production, and from forest fires. And the impact on the food cycle and on food security is really quite large. Globally, it's estimated that about 12% of staple crop yields are lost because of ozone already. And in parts of India, they reckon that up to half of the crop, particularly of wheat and rice, is damaged by ozone. And the figures for between 1980 and 2016 suggest that we could have had a third higher levels of agricultural production on the same land if we hadn't had such high levels of ozone. And of course, climate change is compounding the problem because hotter weather increases ground level ozone production, which increases crop damage and leads to further adaptation costs and challenges. So, ozone is a particularly harmful activity. But just as fossil fuel-based activity harms our diversity, so the way we grow our food actually harms our health and our natural world. And I imagine some of the other panelists are going to talk in more detail about that. But I just wanted to talk a little bit about how agriculture operates as a major source of air pollution. Livestock produces methane and ammonia. Rice paddies produces methane. The burning of agricultural waste produces particulate matter. And the overuse of fertilizers, in particular nitrogen-based fertilizers, damages watercourses and soil health and leads to formation of ammonia again. And ammonia combines with nitrogen oxides to produce particulate matter. And particulate matter is especially harmful to human health. And particulate matter is the agent in the atmosphere that is most tracked by air pollution scientists, and they report on PM10 and PM2.5, and that's the chemical in the atmosphere that the World Health Organization specifically targets to reduce. But unfortunately, the way we've organized our agricultural systems and our intensive agriculture systems leads to the creation of more ammonia, higher levels of methane production, and higher levels of nitrogen pollutants. So that is affecting the very health of the systems that we rely on for our well-being. So what can we do about this? Well, of course, the answer is to reduce air pollution, but that's easier said than done. Unfortunately, air pollution is trending in the wrong direction. In highly populated parts of the world, China, India, other parts of South Asia, air pollution is increasing dramatically. And one would ask, are we tackling this in a concerted way? And the answer is unfortunately not. And I'll just give you a couple of statistics before I finish, just to give you a bit of a sense of the mismatch between the size of the problem and our response. Air pollution contributes to the death of between 7 and 9 million people a year. That's roughly 1 in 5 deaths worldwide. And yet the international development funding that goes into tackling air pollution is less than 1% of total development funding, 1%. And 4 times the amount of funding that goes into air pollution work goes into fossil fuel prolonging investment. So we spend 4 times more of our international development assistance promoting fossil fuels than we do tackling the harms that fossil fuels cause. So this panel is all about integrated, holistic solutions that benefit climate and the conservation of nature. And air pollution is a practical example of where these issues come together really quite powerfully. And air pollution is an issue that we can address with practical measures that limit emissions from fossil fuels and farming for the benefit of the planet and for human health as well. Thank you.
Thanks, Sean. So in a sense, you would say that we, by addressing climate change, we would be having hand at hand, let's say, the air pollution control, so these things work together.
They absolutely work in parallel, but we often make the argument that air pollution is something that citizens can understand, and
Yes.
they can relate to in a way that it's harder for them to relate to climate change. So politically, it's often easier to work on fossil fuel reduction through the lens of air pollution than it is through the lens of climate change. And of course, when you start to talk about, if you tackle air pollution, you also get so many natural ecosystems benefits as well. That's an added argument for taking action.
And so you would say that the own conservation, if you are looking at it holistically, it is compromised if we don't deal with these 2 issues, the air pollution, climate change. Talking about the conservation per se, we find that it's absolutely put at threat.
Correct, absolutely. You need an integrated approach.
Yeah. Thank you very much, Sean. Monia Stephanie is my next speaker. And Monia is a researcher in physics of climate change in France. You can say that better. I'm not going to test my French here. And Monia works with greenhouse gas emissions MRV, monitoring, reporting, and verification with several academics at the Institute. So she has been an expert reviewer for IPCC 6 assessment report, and she was a research fellow at MIT with also with some high top specialists in the program on negotiation. So Mona is going to provide us with a view on conservation coming from energetic processes. So I'm very interested to see this linkage of conservation and energetic processes. Mona, so the floor is yours. Do you have a presentation, right? So
I do.
Yes, okay.
Thank you so much, Thelma. You're such an inspiration for me. So it's a great honor to be with you all, but with a special mention to you, Thelma. Thank you very much. I really appreciate it. Maybe I will stand, so it will be a little bit lively, and I want to challenge my colleague, because you said, to friendly challenge you. You said that climate change is maybe a little bit arid as compared to pollutants, and I would like to make it to show that it's actually not inaccessible or arid. Let's take the challenge and you will tell me, okay? Okay, so next slide, please. So, okay, I will give a definition of conservation, which I'm not an expert on conservation. I would like to talk about energetic process. But broadly, according to Oxford bibliography, which I found, conservation is basically the care, the will for preservation of, Earth resources, whether they be our genes, our human species, or other animals, because we are animals in the order of things, vegetables included, and to maintain actually the diversity of our ecosystems and also of our civilization. Everything I'm going to talk about, it's all about human civilizations, our ecosystem, the ecosystems that we know, that we love, we can say it, that we have been knowing and adapted for a long time, for a long enough period of time. So this is a picture of the beautiful Congo Basin. We are in Africa, so I would like to pay a tribute to Africa with this beautiful picture from the National Geographic image collection. Next slide, please. So let's talk about physics. So biodiversity and the preservation of species, of the beautiful fishes of our environment, is linked intimately, it's intricate with physics and equations. And equations are just tools. They help us to understand the energetic processes which actually govern the Earth balance, because it's all about equilibrium. So these Fourier transform, which may seem arid, I'm not going to go into the details of that. I would just like to focus on the person, on this gentleman, so Joseph Jean-Baptiste Fourier, who is a French person. It's also a way to give a tribute to the country which is most represented on this panel. So in the 19th century, this mathematician actually asked a simple question: if the Earth gets energy from the sun over and over again, why the Earth is not getting warm and warm again indefinitely? And he answered to that from an energetic point of view. His idea that he developed in his memoir at the French Academy of Science, the institution where he worked, also at Polytechnique, École Polytechnique, which is still a French engineering school which was founded by Napoleon Bonaparte. He actually answered to that question very simply. Okay, if it's about balance. If you receive energy, you have to get rid of that energy. It's the law, it's the basic law of energy conservation. So he said, okay, the Earth receives energy, so therefore the Earth has to get rid of that energy, you know? So we receive energy in the domain of the energy that we call the visible, that you all know, the visible light of the sun, in the infrared, the short infrared, and also in the UV. This is what is received from the sun. And Fourier was the first to modelize, to conceptualize that the Earth had a chaleur, what he called a chaleur obscure, okay? An energy that he didn't know, that he didn't put into equation at that time. But he said this energy is getting back to space. And this is what we call now the infrared radiation of the Earth. This is what helps the Earth, next slide, yes, to actually get rid of the energy that it receives from the Earth. And there is a balance, the simple balance. All the thing about climate change and greenhouse gas comes from this balance between what the sun receives and what the Earth gives back to space. It's very simple. It's complex actually, because for instance in this simple scheme, we have a one layer of atmosphere model, we call that. Actually, it's an approximation because it's complex. The atmosphere, actually the temperature goes down with the atmosphere, so the vertical profile of the atmosphere is something which is not, it's complex. But to simplify, this is how it works. And the balance you see on the right, this very, very simple scheme, what we account for is the energy that we receive, okay, at the top of the atmosphere, that comes to the atmosphere and then to the Earth. The Earth gets back some of this energy, and another kind of energy still in the infrared goes back at the top of the atmosphere. And what we call the greenhouse gas effect is just the difference between the balance of those two flux. G, okay, here is the greenhouse gas. It's what is received basically by the sun and what goes back, you know, at the top of the atmosphere from the Earth. It's very simple. And it occurs naturally. The greenhouse effect occurs naturally, and it's a chance. Otherwise, there would be none of us here. If without greenhouse gases, we would be at minus 98 degrees Celsius. There's no possibility for civilization, human civilization, as we know it. So this is a good thing. Just to go back to Fourier as well in Egypt, I wanted to know that, just as a detail, he brought the Rosetta Stone from Egypt to France with Napoleon. It's now in the UK. Okay, next slide. Sorry, it was a little digression. So I work with those great gentlemen that I would also like to thank very much at Laboratoire of Meteorology Dynamique. Philippe Drobinski, he's the head of my lab. Hervé Letreut from the French Academy of Science, he's your colleague. So he was the director of the Institute Pierre-Simon Laplace. And Philippe Siès, who is at the French and Chinese Academies of Science. I would like to thank them very much. Okay, just also, because I'm here invited by the French delegation, a tribute to my country. Just Hervé Letreut, my boss, was received by Emmanuel Macron, our president, also with Valérie Masson-Delmotte, that everybody knows, Jean Jouzel, just to say that this intrication between biodiversity and climate change is taken to account, considered more and more seriously. I think that one of his main sentences that Emmanuel Macron, President Macron, repeated was that biodiversity and climate change are completely, totally, intimately intricated. So next slide, please. Maybe we go back. Okay, so I would like, again, to thank Thelma, because thanks to a panel here, I was expert reviewer. I applied to be expert reviewer for the 6th IPCC report for the working group one on the physics of climate change. Next slide, please. And as we're in Africa, in the 6th assessment report, there was a regional insight over Africa. And you can see here some of the results, the regional results that are provided by IPCC. You see it's super simple. There are beautiful maps. And you can see at one site what is for you see temperature with the logo, okay? For instance, there's a high confidence that the rate of surface temperature increase in Africa has generally been more rapid in this region than the mean of the global mean of other regions. This is with high confidence, and there are probabilities that are assessed by the IPCC lead authors and chairs and very serious scientists working on that in an interdisciplinary way. You can also see that the frequency and the intensity of the heavy precipitation in Africa events are projected to increase almost everywhere in Africa with an additional global warming. Because we talked about greenhouse effect. It occurs naturally, but the emissions that we send to the atmosphere, they disturb the natural balance, okay? Because you add a variable, you add something else in the system, which is put into equations, so you break an equilibrium. And this equilibrium that we are living now, I mean, it's already changing, as IPCC reports show, is something which has not happened for millions of years. So the thing is that, okay, when climato-skeptical says, okay, the Earth climate has not been stable over time. This is true. The Earth climate has not been particularly stable over time. But the problem is not the Earth climate. The Earth will make it without us, without human civilization, fortunately, without ecosystems. It's about human civilizations, and never in the temporal scale of the human civilization, never we had such a rapid disturbance, break of equilibrium. And that was demonstrated with people like Jean Jouzel, for instance, Claude Lorius, etc. That has been discussed first by Jules Charny at the American National Academy of Science back in the 1979, actually. And this is a very, it's like rock solid science, because it was conceptual first. And now we have the data. We have the measurements. So climate change, it's complex. But I think it's pretty simply understandable still. There's basically a break of equilibrium that we have never seen before, and that we don't know what it's gonna, we know that we don't know what's gonna happen, and we know that there's an important threat, an unknown threat on the climate that we, human, but also animals, vegetables, etc., have been adapted to. Okay, next slide, please. So, okay, 1 minute, okay, very lightly. So my research topic, I'm working on monitoring, reporting, and verification, what it is. So in the Paris Agreement, you know that all countries, the signatories, the 197 countries, signatories of who ratified, I think one less, the Paris Agreement, now the United States came back, they all took pledges, commitments to mitigate, to decrease their emissions. But we need to check the progress which is made by the countries over time. And for instance, this year, in 2023, more precisely, there will be the first global stock take. This will be a review, a precise review of the country pledges. So I'm working on ways to challenge the data, the reports which are given by the country, to see, you know, if we can benchmark those data, those UNFCCC data, because countries, they basically have inventory, national inventories, and they report that to the NFCC. So there is a fourth group, we have 3 groups at the NFCC, plus a national task force on greenhouse gas inventories with Eduardo Calvo. And what we do with Philippe, Hervé, and my team, we try to look at satellite inversion to see if we can basically challenge the bottom-up, the data which are provided by the country, with other things, with independent data. And it's not easy. It's complex. The inversions actually work with different stuff. So we basically use a material which is not pure. Satellite data use a priori fluxes, so we use basically data which are also bottom-up from statistical inventories, like for instance the International Energy Agency or the Global Carbon Project. Then you have to use what we call an atmospheric transport model, which is a model with equations where we try to put all the equations, the variables, the complex, this is complex, of the atmospheric transport, which are governed by the Navier-Stokes. This is complex equations. This is, okay, not easy. And then from that, we go to concentration. And for data quality, we want to calibrate these things with observation. Anyway, I just wanted to say that, okay, it's complex to do the MRV, and I would like to really thank Thelma and all the panelists for their patience. Thank you.
Thank you, Mona. Thank you very much. You could go forever, and I would let you go forever if we didn't have, you know, a time limit into this. And so I'm not going to make any question to you at this time to leave, you know, the audience to make questions later. So with that, I introduce Christophe Moquet, that has a PhD on marine biology and has a passion for the ocean, as all of us do with all the work that we do. And so he strives to bring together the scientific, environmental, and socio-economic dimensions of the marine world to value and better protect its treasures. He has been promoting blue growth for sustainable development of communities for 10 years in a business school and non-profit organizations. Today, he is the director of the Marine Resources Science, Conservation, and Innovation Program at the Université Côte d'Azur. So with that, I thank you very much for being with us, and the floor is yours.
Thank you, Thelma. Thank you a lot. So we are here supposed to talk about comprehensive conservation, the challenge and the emergencies related to that. I would like to emphasize the need to combine protection with the sustainable community development as well, with a focus on marine conservation, and by also proposing interdisciplinarity in higher education as a key element. So the unbreakable connection between environment and economy has been established already from the 19th century, short on history, by economists, naturalists, clerical people. Maybe you know Thomas Malthus, who connected the limited resources access to wars. David Ricardo, who anticipated the affliction already of intensive agriculture. Ernest Haeckel, an ecologist who was seeing ecology as economy of nature. And Pareto, who demonstrated that we need to find a balance between the different use of resources. Next slide. Here I want to mention one person in particular, who's Kenneth Boulding. So we are in the US in the 60s, 70s, and we are actually in the midst of a protest movement due to the intervention of the US, the American military intervention in Vietnam, but also because of uncontrolled development in the US having effect on the environment and the health of Americans. And in this movement to reflect on our impact on the planet, Boulding theorized sustainable development for me by connecting value production in economy with environmental protection. So as you can see on this diagram. So in contrast to a freewheeling vision of the economy that use inputs and generate outputs, like the throughput economy, he called that, he demonstrates that the creation of value creates in turn waste that of course ultimately impacts the environment, that turns to be our main capital, producing resources for this so-called value chain. So he uses a very fancy expression I like, spaceship economy. We are all in a spaceship and we really have to be cautious with the resource we use. Next slide. And this connection between environmental and socio-economic issues has taken a modern twist now with the UN SDGs, which encourages us to conceive any problem and hopefully any type of solution by integrating these different dimensions. And if we get closer to our subject, so today conservation, and for me marine conservation, it turns out that we cannot solve issues related to SDG 14 with the sea. Next. Without offering societal solutions on poverty, inequality, hunger, and for that also to propose alternative economic business models to communities. Next slide. Alors, I will just use a few case studies. For the first one, I would like to go to Madagascar. There, some communities are of course in state of overfishing. they have to go farther and farther away to find fish. Of course, fish, which are becoming more and more rare. And so the local population, of course, they can see that there is a problem with overfishing. So going there just to tell them to stop fishing will make no sense. So I would like to talk about an NGO that worked with the communities to see what could be done, of course, scientifically on the protection aspect, but also something that can work for the people. So practically, they were able to redirect part of the development model which was on fisheries, something that was not working anymore, to sea cucumber farming that reduces the pressure on the fish communities. Next slide. So what is needed to protect the ocean? I think when we develop like a marine protected area, we need a clear management plan based on scientific evidence, a full understanding of the ecosystem situation, but also effective measures that have to be enforced, such as no-go, no-take zones. But the goal, for me, is not only to protect the fish, it's especially to ensure sustainable development of the communities. So for this, these protection measures may be, of course, first financed, but also taken in consultation with the locals. I would like here to highlight 3 examples, and as you said, we are largely represented by French community. So 3 examples of French examples, partners of Université Côte d'Azur. Here, Blue Seeds is a startup, and a startup has a business model. The business model of this startup is to create business model for marine conservation. So Blue Seeds helps to help marine conservation stakeholders to build a sustainable financial strategy. There are practical possibilities like MPA concession fees, visitor fees, mooring management, community-based entrepreneurship, innovation, and adaptation of fishery practices to small-scale fishing. Quickly, Blue Finance, so it's another operator of MPAs that actually participate to different MPAs worldwide. They combine scientific and socio-economic aspects. They develop blended financing, actually, public-private financing of conservation. And the last one, Coral Guardian, is an NGO, historically positioned in Indonesia, where some communities, mid-term historically, still use blast fishing, so explosives in the water. So of course they know that it's not a good idea, and by the way, this practice has been imported by Westerners. So once again, the idea is to come and provide a solution. But before Coral Guardian, another Western NGO arrived and unilaterally proposed an MPA. And you know what? They decided to enforce that protection with shotguns. And you know what? They used the shotguns. And they had to leave quickly after. So Coral Guardian came afterwards. In this complicated situation, they had to restore the trust between science, environmental protection, and development of the community. And what they've done practically is to use ecotourism only initially to create a financial flow that they used afterwards to restore part of their reef. And after 10 years, they have restored a large part of this reef that can be seen as a natural capital that now again generates ecosystem services to the population, such as fisheries, for example. Next and final slide. So all these success stories are success because they combine scientific and socio-economic aspects. And we all know, and maybe you know at IPCC a lot, that it's really difficult to find somehow the right channel to communicate between these 2 dimensions, these 2 spheres that have their own language, acronyms, jargons, but also, let's be clear, different ways of thinking as well. So I am convinced that university has a prominent role to play here through higher education. So I am heading like a master program, international program in science, marine science. So maybe I'm not the good one, you have to listen because I'm biased, because we have created such a program that opens science to conservation, to actually economy, socio-economy. So I'm just hope that more and more scientific programs will open their training to socio-economic dimension to find innovative and sustainable solutions to our global issues, because marine conservation is not only about saving fish, but also ensuring the sustainable development of the communities. Thank you.
Thank you, Christophe. Yeah, we can feel your passion for your work. Yeah, I always find it very difficult when you're trying to bring science on the table with communities that can see the science to threaten their livelihoods, the way of that they are bringing the money to home and keep their lives. You talked about success stories, right? But I also like to explore stories that sometimes do not end up as successfully, because that's a learning process as well. And I would like to ask you if you have knowledge of something that did not work despite all the efforts to bring and put the science on the table and ensure that you could, put together livelihoods, communities, and protection and conservation of the environment. Do you have that?
Yes, I think it's a long process before it becomes a success. So I think all of the examples I used here actually pass through a lot of non-success before becoming a success. I use, for example, the idea of coming on a place with our big hooves as Westerner most of the time, and explaining that we have to protect to save the fish, not regarding what happens on the communities, not bringing an alternative business model, I like to call that, even if it's not nice word in science sometimes to talk about business model. So yes, of course, we have plenty of situations that doesn't work. And I talked about connecting conservation to communities. The other aspect, I think, which is important that I mentioned briefly, is that we have to finance also that. And if we want to take one example, Blue Seeds again, they propose a lot of possibilities, as we say, to bridge the financial gap between the money we can get from, let's say, governments or charity, but this money from charity often comes with an agenda coming from people who give the money. So the idea here is to develop our own financial flow so that conservation is free from agenda of people giving money. So for a long time, main problems for me were that, and still now, conservation is not efficient because of paper parks, because it's just a large area on a map which is not financed or not protected. And also, if this conservation does not integrate the local communities, and there is no acceptability of the measures.
It is fantastic and challenging, I must bet. Okay. So thank you very much, Christophe. So with that, we are going to have now a talk by Agatha Uzen. She's a research fellow at CNRS for now 20 years or a little bit more, and in anthropology and environmental sciences. As a scientist, she studies the environmental representation and water perceptions and how people use water in different contexts, including at the domestic level. So she is also the Deputy Director of the Environmental and Ecology Institute at CNRS. She co-leads a big program called One Water, and she's going to guide us through this impressive national research and innovation program to accelerate transitions, measure impacts on social hydrosystems that seeks to respond to current and future challenges from global change. So with that, Agatha, thank you very much for being with us, and the floor is yours.
Thank you very much for the invitation. It's an honor for me to be there and with you. So yes, we begin with air, energy, ocean. So there is another element, water. Water is everywhere. And we can see with the different crises that we have, climate crisis, biodiversity, health crisis. So water is on the earth of each of them. And then we have to consider the socio-ecosystem in their all approaches. Water is life. And without water, we crystallize that there is some problems in the environment. And there is some trajectories that we have to better understand to be able to protect and to preserve our life. Human, plant, animals, and just the earth, and the good quality of the earth, for now and for the future. And we have the past, and we have to consider what we did before to be able to do something better, maybe, in the future. Regarding water, what is extremely interesting is to know that generally we say, oh, we don't have to consider the question of water. We have it, and then we use it. And we don't ask about the disponibility and the durability of this resource. And just we realize that the value, the real value of water, well, you turn the tap, but nothing is coming. So what's happened? And then you realize that maybe we have to change something. Because with the climate change, with global change, with increasing of demography, littoralization, urbanization, the increasing demand of food, the circulation, and so on. So we have a real impact on the resource. And then, even if we consider that water is in a big cycle, so we don't have to think about, we just have to think that now it's not the same. Something is changing. And then you have to change our mind and to shift our perceptions to consider water as a common, as something that there is some value, and not to consider water only as a resource that we can keep and use without interest about the renewability and the quality and the disponibility for everybody and for every uses. In France, we have the chance to consider the water governance for a long time with different laws, and they consider the management in a basin, and then they include different users to manage to develop the water management with integrated approach. But you know, it was not considering the trajectories and the evolution and the increasing pressure on water because of climate and the other things. And then we consider that we have to change the paradigm and to be able to consider water as his disponibility, regarding the disponibility, to develop certain uses and to change the uses in relation with the disponibility of water and the quality of water. That's why we promote this big program, which is One Water. And first, we would like to better understand the evolution and the trajectories of the disponibility and the quality of water. We have to cross the different data that we have. We have a lot of data, many data, but sometimes it's for each department or silo or institutions. But we have to share the data and to cross some of them, sometimes some quantitative with qualitative data, to have a better know the impact of the territories, of the management, the land on this resource. Secondly, we also have to observe the evolution of the impact, anthropogenic impact on water, and how water is able to do to interact with the other compartments, and then the incidence on the quality and on the quality on water and the evolution. And so also water is life, and if we have an idea about the quality of water, we sometimes have the idea of the quality of the ecosystem and of the health, human health. And then it's a good indicator, and we have to preserve this indicator as a resource. With all of this information, we should be able to change our perceptions from scientists, but also with all the stakeholders which are in charge of the management of water to decide to manage the different territories regarding this big resource that we need everywhere and every time. So this program is try to involve a lot of people and a lot of researchers from different sciences. But we aim to develop sustainable sciences. Then we will consider the interdisciplinary approach that we need to develop, but also to integrate the empiric knowledge which has developed by the different stakeholders, who knows territories, who knows process, who have some knowledge, and then we have to consider all of this information to be able to promote everyone a new solutions, new response, to be able to have holistic management, more integrated management of water. It's one example that I want to show you and to say probably that we speak about water conservation, but we need some knowledge to be able to conserve in the right place, in the good time, for durability, and for everybody, that we have to consider all uses to be able not to develop some inequalities, because we say we have to preserve, so it's another question about that. And then with this example, we can see that everything is connected in the environment with human, from time, space, and human are in the core, in the earth of the system in relation with water.
Thank you very much, Agatha. It's very impressive. So you are absolutely right. The way well, water is one of the critical elements that we have when facing climate change. So if we take, for instance, the Andes in Chile, and the agriculture that depends on the water melting also. So, and when you say this integrated view, so you may not have any more, or you're going to have more sparse water coming from the melting of the snow that, is the water used for the agriculture. And then you don't have that for the small farmers. And then you have migration. So you look at this interconnectivity of people having to migrate to other areas. Normally they move from the rural to the urban, causing even more problems. So when looking at water and looking from more holistic way of all the uses and understanding it as a common, it's important. Just one question that I had is, so this program, how long has it been in place with financing, and how long is it expected to last?
So it's a new one. It's a new program.
Okay.
It just became. It's in French government actions. It's I don't know how can I translate. So it's a specific big program in France to promote some money in research regarding emblematic questions and topics. And this is one of the first winner program, and it's for 10 years. It is 53,000, 53 million for 10 years. And then we have to involve all of the scientific community, but also the other stakeholders who are concerned on water. So from people who are directly concerned by water, but also some people who are unfortunately connected because of their activity.
Okay, thanks. So when you say about this interdisciplinarity, do you mean that you are also engaging researchers from other places, or it's mainly France?
It's focusing in France.
Okay.
Yeah, but we hope that we will be able to transmit and to develop this kind of new paradigm to be able to change really.
No, definitely. I think this is a seed that will potentially motivate others to do the same. So thank you very much. It's an important area of research. And now finally I come to Thibault Malloze, who is a research director at the French National Research Institute for Agriculture, Food and the Environment. And his research focuses in the biology of insect populations in agroecosystems. And he's also a coordinator of the French Public-Private Consortium for Research, Development, Innovation on Pest Biological Control. So Thibault is going to talk about the challenges related to conservation and agriculture. Thank you very much for being with us, Malloze.
Thank you very much, and thank you for the invitation. It's really a pleasure for me to be here. I will talk about the last system we didn't talk about today, about terrestrial ecosystems. It came back.
Yes.
And well, I will share with you some thoughts about the interaction between agriculture from the one side and biodiversity on the other side. Next slide, please. So first, let me remind the context that is relatively dark, actually. Well, as you may know, and you probably heard many times this week, agriculture covers a large part of the terrestrial surfaces all around the world. And agriculture is a primary driver of terrestrial biodiversity loss. And the main drivers that have been evidenced are habitat loss, are the uses of agrochemical inputs, fertilizers, agrochemicals like pesticides also. It's also a driver of biological invasions that pose threats to biodiversity. And finally, it contributes to climate change. Next slide, please. And so, from this scientific evidence, we got to the conclusion that the status quo is actually not a viable option. And, well, the facts are very clear. Dominant agri-food systems are highly unsustainable currently. Short-term benefits for stakeholders are actually very little when compared to the mid or long-term impacts on biodiversity and even for food production. Actually, I put there a graph that summarizes that, and we can see that there is a sort of autocidal effect with agricultural production that contributes to climate change, that contributes to more invasive species, that destroys biodiversity, and all those effects actually have a negative feedback on agriculture. So even from a point of view of agriculture itself, this is absolutely not sustainable. And it's not going to get better because the demand for food is increasing. Next slide, please. Another element I want to share with you is that we got to the conclusion also that all the remanency of the dominant systems all around the world are very influenced by the persistent use of pesticides and chemical pesticides. They are clearly the cornerstones of current systems, of dominant systems. Well, I will not present all the graphs, but the idea is that overall they create the characteristics of the system that reinforce the dominant system. For example, they destroy biodiversity, which reduces the natural pest control, which in the end requires more curative products that are actually chemical pesticides, and that excludes alternative methods such like biocontrol, for example, or increasing of biodiversity. And also from the point of view of infrastructures, agricultural infrastructure, agri-food systems, everything is for pesticides. And so anything else is like not strictly cost efficient at short term. So it's really excluding all the possible ways out from pesticide. And so we are really in a sort of locked system. Next slide, please. So all this to say, well, we definitely need and urgently need to change of paradigm and to switch from agrochemistry that was created just after the Second World War to agroecology. From dominant food systems that are based on agrochemistry and intensive farming, monocultures, to more tailored systems that will be very different depending on the place, depending on the socioeconomic aspects. And we need these place-based strategies based on agroecological principles. How can we get there? Because it's, well, easy to say, but more difficult to get done. It's clear from now like 30 years of policies trying to reduce the use of pesticides that most policies worldwide have failed. They are all based on the idea that we can try to integrate, combine, but keeping pesticides as cornerstones. If I look at this graph showing the possible way to decrease the use of pesticides and to go from agrochemistry to agroecology, then, well, there are actually two options. Either starting from the dominant systems and reducing step by step the consumption of pesticides, but we see that the system is too locked because we continue to keep pesticides inside. And so what we currently propose is to, well, take all the system all the way around, starting from system with no pesticides and trying then to increase their sustainability and productivity. Next slide, please. So what do we advocate for in terms of research and innovation? The first thing and very important message I want to convey today is that we really think that we need to think in terms of research in a world without pesticides. Otherwise, we are going to increase the efficiency of sprayers, we are going to work and spend money on improvement of combination between pesticides and biocontrol, but this is a waste of money. Actually, we should definitely try to be more innovative and more creative. And this is an idea that we are currently proposing in several large-scale initiatives at the level of Europe in an alliance called Towards a Chemical Pesticide-Free Agriculture, within a new initiative called Agroecological Crop Protection, gathering 50 institutions all around the world, and we are promoting this idea. Next slide, please. And overall, the pathways we wish are on two different aspects. The first one is to continue to provide evidence that indeed agroecology is not just a wish or poetry. It's clearly sustainable, and we need scientific evidence for that. We also want to increase the number of co-innovation programs to make systems tailored to each system. And we also promote research and innovation on all the agroecological levels: agronomy, biosolutions, intra and interspecific diversity, machinery, digital tools, social sciences to support policies, etc., etc. Next slide. In terms of actions, I want to make clear that the idea in these initiatives are not to blame farmers. Farmers are clearly not the ones to blame. They are locked. They are actually victims of those systems. And so the key priority is instead to engage the value chain players to ensure that farmers receive additional incomes if they implement practices that increase the level of sustainability. And so the priority targets are not farmers. They are mainly downstream players, agri-food industries, retailers that have a lot of levers available, and even consumers, of course, land management players as well, policymakers, and all the people around providing training, knowledge, like advisors, teachers, all training players. And I thank you for your attention.
Well, thank you very much. This is really interesting, and well, that's our vision as well, that the problem is not with the farmers, it's with the big agribusiness. So when you say, yes, you mentioned that agroecology is sustainable, My question is inevitable. Is it profitable? As it's inevitable, right? Because when you come to talk about, to the big agribusiness people, and you say, well, you try to explain to them, the climate change issue, they need to change the way they are doing business. So they think that this is, the response is, this is too far away. There is not a vision that this is going to happen now. So why am I going to change the way I'm doing business if I'm not, if that is not going to affect me? So there is this vision of the timing, which makes it very difficult to convince people to the transformation that we need to do in all sectors. So do you have any feeling about this?
Well, that's a complicated question.
I know.
But the first element is that, from a theoretical point of view, of course, it's profitable in terms of sustainability, value, economic sustainability. It is. And then the problem is really the business model of the players, of the value chain. And so, of course, if you don't change the business model, definitely short-term profits are not there. And that's why I'm saying we really need to change the business model from the bottom of the value chain, from the downstream players, because otherwise you don't change the rules, actually. Economic players think about profits, economic sustainability, and so we need to enter the system through the bottom and change the rules, and that's why I'm insisting on retailers. Because if retailers ask for certain features, then agri-food industries will also change, and then all through the process. And I think that can change the view of people if you talk the same language, the business language, and not only like ecology and things that looks like far away from them.
That's perfect. So, thank you very much. And now I open the floor. Yes, Patricia. There, you can take this one if you want.
Thank you so much. I'm Niri Vulul Naraul Zhao, head of the Meteorological Office of Madagascar and IPCC National Focal Point, a former Working Group 2 Bureau member. Glad to see you again, Thelma. It's a long time. So I was very interested by your presentations. Thank you so much for the panelists. As you know, Madagascar has a unique biodiversity, and biodiversity conservation is really a matter of urgency in Madagascar. For example, this year, 2 years ago, we started to monitor air pollution in Antananarivo. And in October, because of forest fire, the threshold of the WHO is every day 3 times above the threshold of WHO. And on the other hand, I don't know if you are aware that in September, whales came to Madagascar. And this year, more than a dozen of these whales were washed up on the beaches of Sainte Marie, up to the beaches of Fort Dauphin in the southern part of Madagascar. And it's a very, very big issue. Nobody can say exactly what is the cause of this phenomena, but each year we have whales come to Madagascar, but we have never heard of this death of whales on the beach of Madagascar. And also each year we have people who died from eating fishes or sharks from September up to maybe November. And in spite of some governmental information to say people, please don't eat shark or this kind of fishes from September up to November, each time we have death from eating these ocean products. So What do you think about this case in Madagascar? You are showing this case of Madagascar in, I don't know where is the place. Where?
The south of Madagascar.
Southern of Madagascar.
Yes, in southern
Southern of
Madagascar. It's with
Madagascar.
Blue Ventures.
Blue
the NGO.
Venture, okay. So I would like to know what is your position or your explanation on this case in Madagascar, these whales washed up on the beach of Madagascar. Is it because of warming ocean or what? Because in Madagascar, adding to the global warming, there's this huge forest fire every year, everywhere. Thank you.
I'm afraid I won't be able to answer about the cause of death of the whales. I understand there are migratory species, so it's maybe not what happens in Madagascar that can cause these deaths. But maybe coming back on you were talking about the fact that people die also, despite the fact that it's forbidden to.
Yes.
But a little bit like what has been said just before by Thibault, we cannot blame the farmers, we cannot blame the fishermen, and we cannot blame the people eating the fish, because I guess I'm not an expert of the area, but I guess they have no choice but eating this fish. So I understand we have to provide an alternative. I will come back to what I said, like when we come to solve a problem with fish or whales or whatever, we have also to come with an economic alternative. So that's why we have to work together, scientists in natural science, with scientists in economy, and people involved in that. I'm afraid I won't be able to understand much further about ecological aspects.
That's okay. Unfortunately, we have to close, but maybe that answer will come in the next cycle of the IPCC. You know, maybe some research on this issue will come up and possibly be picked up on the, in the next assessment cycle that starts next year. So not a very quick answer, I guess, but at least I think it's going to be a research study on the possible causes. So with that, I would like to thank all the presenters. Thank you very much for being here. It has been a very rich session, and having conservation from many different aspects, many different ways. So this is why I find it very stimulating, and would like to thank you very much and ask for a round of applause to all of them. Thank you. Yes, thank you, thank you, thank you. And congratulations for the work you all are doing. Thank you.